Okay. So Vivan, AI will keep aside. We have Vivan, we have Thanu, Dikshita, Garima, and Arav and Advik in the classroom. So we'll get started. Some of the kids are still missing, but I know many of the kids are actually not well because of changing weather. So first thing first, in the last class, all the 4 things are to be finished before coming to the class. Food is not to be brought in the class. I mean, if you're hungry, you can still have it, but make sure that it's done. It's done before you come to the class. Okay? Food, drinks, coffee, cold drinks, soda, everything to be finished before the class. Okay? All right. So we have Shiran also. So all right. So in the last class we were doing. Huh? Pythagorean. Okay. I also remember a lot of things. Let me see again. You guys don't have to keep on interjecting between each and every word or combination of words. Okay. Otherwise, I lose my chain of thoughts and you guys will not learn anything. All right. So now Sami also is here. Okay. So I was saying that in the last class we learned Pythagorean theorem, where we learned how the Pythagorean theorem came to existence. That was the first thing, and then we tried solving few problems using the Pythagorean theorem as well. Now, first question to you guys, before I can start sprinting with the next topic. Is there anybody in the class who is not clear about what is the Pythagorean theorem and what is the underlying concept for that we have used for proving the Pythagorean theorem? It has to be a valid question. That's the word.
There is one question in the assignment that I need help with.
Okay, we'll come to that. Okay, so right now I have asked one thing, that anyone in the class, if you are not clear about what is the underlying concept for Pythagorean theorem, meaning where do we use it, why it is used, that is one thing. And second thing is, what concept did we use for proving that theorem? If you are not clear about these two, you have to shout it out now, so that before we march to the next topic, at least we know that we have covered everything that we need to cover. Yes, sir.
Wait, what were the questions again?
The question was that in the last class we learned about Pythagorean theorem. What is the Pythagorean theorem? And then we also learned how did that theorem come into existence? What is the underlying concept which gave birth to Pythagorean theorem?
I'm not sure about the second question.
Okay.
Like how it came into existence.
Okay. That's a good point, and that's an honest point. I mean, you guys have to leverage this platform for asking those questions. Wherever you have doubt, please ask for it so that we can cover that. Okay, Bivwan, are you clear, beta?
Yeah.
Sanvi, are you clear? Dikshita, are you clear?
Yes, sir.
Garima, are you clear? Yep. Okay. Ashrit. So now, let me ask my question one more time. If I have two triangles, okay? If I have two triangles, triangle ABC, let's say I call it ABC and I call this as DEF. Okay? I have two triangles. Are they looking same?
No.
They are not looking same, right? Okay. That is one good observation. Why they are not looking same? Because the sides are of different length, right? This one looks much bigger side, this one is smaller side. Likewise, this one is smaller, bigger than this one. All this. Okay? Now, if I say this angle, let's say 40 degree, okay, and this angle is also 40 degree, this angle, let's say 80 degree, this angle also 80 degree, this angle 60 degree, this angle also 60 degree. What are these two triangles called? I'll come to you. What is that?
Triangles, Callie. Because
No, because You made a false start in the first place. I'm talking about two triangles having matching angles. You are saying a scalene triangle.
Oh,
So hold it now. Your option is exhausted for next till next question is asked. Okay.
You make good triangles.
That is not the question. Okay. Anybody on the screen? I have two triangles A, B, C and D, E, F. This angle is 40 degree, this angle is 40 degree, this angle is 80 degree, this angle is 80 degree, this angle is 60 degree, this angle is also 60 degree. What are these two triangles called? What is the relationship between them? Yes, Vivan.
They both are equally proportional. Like similar figures.
Okay, that's
They're
one.
similar.
They are similar, okay. How about you, Shreya?
They both are congruent.
No, that will be a blunder, okay, never say that.
Okay.
Actually, I have a real one.
Huh?
I have actually a real one. One is zoomed in and one is zoomed out.
Okay, that's one. Okay, Dikshita, what is your response?
what's the question again?
But the about to say that
You missed it. You missed it, so wait for next question. Yeah, Dikshita.
I was about to say it was congruent.
No, congruent will be a crime, okay, never say that. Because congruence means exact copy of each other, exact replica, like my both hands. You can probably say they are congruent because if I flip it, you will only see one hand. If my hands were distorted like this, then they were not congruent because both were of different sizes. So when you say congruent, you are saying exact copy. Okay? So, and they are not the exact copy. If I overlay this one on this one, you will see the bigger triangle. If I overlay this one on this one, the smaller triangle will be disappearing completely. Yeah, Vivek.
it's proportional.
Okay, so let me not take you guys to places. Garima, any answer from your side? Okay, so if I have two triangles with matching angle, this angle is matching, this angle is matching, this angle is matching, they are called similar triangles. In practical life, if you want to relate with that, it's like a zoomed in, zoomed out version. If you zoom out, meaning you make this picture smaller in your phone, you will get this one. If you zoom in on this one, meaning you make this picture look bigger, you will get this one. When you are essentially relating something with a zoom in, zoom out thing, you are talking about similar shapes. Okay? Like what Asvik said, zoom in, zoom out is just a practical example that we all play with every day on our phone. That is nothing but a concept called similar shapes. Here in the case of a triangle, these are similar triangles. Okay? Now, so we use the same concept. So basically when triangles are similar, meaning their sides are in the same proportion. Meaning if this angle and this angle are same, then their sides, meaning side opposite to this one, BC, this one divided by this one, EF, will be in the same proportion as the other angle which is matching. So this angle are matching, so side opposite to this, AC divided by DF will be equal to the third angle. This angle and this angle are matching, so look at the side opposite to that. AB divided by DE. So meaning when the triangles are similar, their sides will be in the same proportion. Meaning if you are picking the one triangle's side in the numerator, make sure that you are picking the same triangle sides in the numerator, and the matching in the denominator you put the side which is opposite to the matching angle. Okay? Is this part clear so far or no? Anybody? Yep. So basically we use the concept of similar triangle to find out the Pythagorean theorem. And Pythagorean theorem is nothing but it's a theorem that is used for dealing with right angle triangles. So if you have a right angle triangle like this, why it is a right angle triangle? Because one angle is 90 degree. So it's a right angle triangle. Pythagorean theorem says that this sorry, if this side is A, this side is B, and this side is C. C is nothing but your hypotenuse, the longest side of the triangle, meaning the side that is opposite to your 90 degree. So Pythagorean theorem says A squared plus B squared equal to C squared, meaning the two sides that make the 90 degree, square of the two sides will be equal to the square of the hypotenuse, or the side opposite to the 90 degree.
So the hypotenuse is always the biggest side of the triangle?
100%. Okay? So the question here was, is the hypotenuse always the largest side of the triangle? 100%, no question about it. If you, other thing, just as an analogy, if you want to keep with you as a concept, if you have a triangle, you would observe that wherever you have the biggest angle, the side opposite to the biggest angle will always be the biggest side. If you are looking at an equilateral triangle, what is happening? All the three sides are same. That's why the side angle opposite to that also is the same. And that is how it makes 60 degree each to make it 180 degree. So any triangle, okay, any triangle. I mean, there are sine and cosine laws that we will learn anyways when you guys grow up a little bit more. That is when we will learn those where there are different formulas that we will use, but conceptually if you want to see, look at this triangle. This angle seems to be the smallest angle, right? So the side opposite to that will be the smallest of the three sides. If this angle seems to be the biggest of the three angles, right? Then you see this side is the biggest of the three sides that you see on the board. So the angles and sides are in the same proportion also. Within a triangle itself, the biggest side is always opposite to the biggest angle, or vice versa. Okay? Is it okay to relate? Yeah? So we use the concept of similar triangle to find out this Pythagorean theorem. I'm not going to prove it again because that is there for you guys from the previous class that you can always relate to. But in the summary, what we did was we picked up a right angle triangle to derive the Pythagorean theorem. We picked up a right angle triangle. From here we dropped the perpendicular. We dropped the perpendicular on the opposite side, which actually split this into two right angle triangles. This right angle triangle and this right angle triangle. And then by analyzing further, we found that this right angle triangle is similar to the large triangle. Similar to the small right angle triangle is also similar to the large right angle triangle. And from that we use the formula of the ratio of sides to find the Pythagorean theorem. Okay, and I would prescribe you guys to get your hands dirty, draw a triangle by yourself, put the concept of similar triangle, put the ratio, and then that should help you to derive the Pythagorean theorem if you want to. Okay, I mean, I don't think here, I mean, in my school times, I remember we even had questions for proving the Pythagorean theorem, wherein I have not seen that being a case for you guys here. Okay, I mean, I did not see my elder daughter proving the Pythagorean theorem by herself. She is all set to go to college next year. I mean, this year, not next year. So basically, even if you don't prove it, you are still fine. As long as you know what the Pythagorean theorem is, you should be okay. But it is always good idea to make sure that whatever formula or the concept that you come across, you go to the root of it to be able to make those concepts as your concept, so that you know how to tell, no, it's my teacher who told this is the Pythagorean theorem, so that's why I'm using it. You should say with conviction that yes, I'll tell you why Pythagorean theorem came into existence, and this is how you do it. Yeah? Alright. Now, I'll probably use this class to see if anybody has any question with respect to the assignment that I've given. Like Arav was saying, he had some doubt with one of the questions. So I will try solving it for the benefit of the whole class. But anybody else in the class, if you had any struggle or difficulty in solving those assignments, please raise your hand and don't be shy about it. It's okay not to know. It's not okay not to say what you don't know. Okay? Yeah, Tanu.
On the first page, number 5, I have a question.
Okay, number 5. Let me note it down so that we can try solving those problems one by one. Number 5. Okay, that is 1. How about you, Dikshita?
Page 1,
Uh-huh. So this
number 4.
okay, this is so page 1, number 4 and 5. These two are the troublesome problems, okay? How about you?
2.
Number 2. Randomly you are saying 2? Well,
Page 1, 2.
I need the
okay.
like some like type of like device so I can see like which question.
What is that?
I need to see the question again because I remember like the problem.
No, so this is not going to be acceptable. If there is a question that troubled you or bothered you while solving it, it should be in your notebook saying that, okay, sir, when I was solving this one, I have taken note of that. It has to be a commitment both ways.
Question 11.
Question number 11 on which page?
I don't know.
Huh?
I don't write pages down.
Okay, 11. Question number 11. So there are 4 questions. How about you, Garima?
I think it's
Sanvi?
page 3. I think it's page 3.
Okay, that's fine. Yeah. No questions, Garima? How about you, Sanvi? No questions for you? All good? Okay. Sian, how about you? Any question that bothered you?
No, sir.
Okay. Vibhuvan?
No.
No? Pranav, any question from the assignment that gave you enough trouble?
No.
No? Okay. Vivan, no questions? How about you, Ashrit?
No.
No questions? Okay. So then, I have got 4 questions. Question number 4 and 5 and 2 on page 1. And question number 11. I don't know which page it is in, but I'll figure it out. Alright. So let me go to my own assignment and see what were those troublesome questions for you guys. Okay. So number 2. Okay. Number 2 says, I'm just drawing it, okay? 3 meters. How long is the diagonal of this square? How long is the diagonal of this square? And the options that we had were 3.2 meter, 4.2 meter, 5.9 meter, 8.5 meter. So, look at this one. This is a square and one of the side is given as 3 meter. How long is the diagonal of this square? Now when you say diagonal is nothing but the 2 opposite corners. Either you pick these 2 corners, or if you don't like these 2 corners and these 2 corners look better to you, you pick these 2 corners. Any which way is fine. Okay? Okay? Now, question is, how long is this diagonal? So basically you have to find out the length. Now, going back to the property of the square, if you look at a square, what do we know? Any square, all the 4 sides are same. So if this is 3, this is also 3. This is also 3. This is also 3. Make it as simple as you can. It might sound stupid at times, but that's okay. Make it as simple as you can. It's a square, all 4 sides will be the same. No confusion. You have written it down. Now the question is, what is the length of this one? Another property of the square, if it's a square or a rectangle, you know all the 4 angles are 90 degree. Meaning this angle from here to here is 90 degree. This angle is 90 degree. This angle is 90 degree. This angle is also 90 degree. Okay? Now, if I give it a name, A, B, C and D. This is my square. I know all the 4 sides are 3 meters and all 4 angles are 90 degree. Now our objective is to find out the length of this colorful line. This is my colorful line, diagonal, which I will call as diagonal. To find out the length of this green color line. So, now if I look at this triangle, ABC, if I look at this as a triangle ABC, from here to here, or let me color it for you guys, so that it becomes more optically appealing or visible to you guys. Okay? I'm talking about the green portion of this shape. It is nothing but a right angle triangle. This is 90 degree and this side is 3, this side is 3. Now, our uncle, Mr. Pythagoras, who gave us a theorem, Pythagorean theorem.
Was it Pythagoras?
Doesn't matter. I'm so very mean. I'm very mean person. I only know him for a reason. And that reason is he has given us a Pythagorean theorem. That's it. I don't want to even know about his age, whether he's alive or not. I don't really care. I'm a very mean, miser person, man. I want to only take the best thing out of everybody. Yeah?
I think he's dead.
Okay, so whatever it is. Now, our Pythagoras uncle has given us a theorem called a square plus b square equal to c square. And a and b are the two sides that are making 90 degree. So this and this are the two sides making 90 degree. So 3 square plus b is again 3 square equal to c square, or this AC, this length AC square. Now 3 square plus 3 square is how much? 3 square is 9, 3 square is 9, 9 plus 9 18. 18 equal to AC square. That means AC will be equal to square root of 18. Now, okay. Keep your calm. Take a deep breath at time. That helps. Now, I have 4 options here. I will tell you guys, okay? What happens is, if you don't think, you will put a lot of effort. That 10 seconds of extra thinking helps you save a lot of time. It's a multiple choice question. You can always find out the square root of this one using calculator or by doing it yourself. But hold it, let the teacher do his job. He is paid properly. Okay. Now, you can find out the square root, and that will take time also. But you can apply your brain here. Now 18, you know that 3 square is 9, 4 square is 16, 5 square is 25. If I have to find out square root of 18, it will be more than 4 and less than 5. How many such options you have?
1.
Why do you want to waste time calculating this even?
Yeah, that's why that was to like round it off to other powers.
So this is a very important trick. When you guys are dealing with a scenario like this, right? I mean, for you guys, even the SAT exam is going to be a multiple choice question. Multiple choice exam actually. For every question you'll have.
Well, SAT allow calculators or not?
Don't worry about it for now. I'm saying, you know how to calculate any which way. I'm saying, even in the best exam that you guys are all shooting for to get admission to higher colleges after a couple of years, there also will be multiple choice. And this is a strategy. You have to rule out the option that doesn't hold water for you. When you have to find a square root of 18, you know that it is going to be more than 4 and less than 5. Because 4 square is 16, 5 square is 25. It's more than 4, less than 5. How many such options you have here to deal with? Only one option. Then you don't really have a reason for being confused at all. Advik? Don't make that sound. That is not funny. And this was your question, by the way.
Okay.
So, if you ask the question, if you have an intent of learning this one, you have to pay attention as well. So, your technique called elimination helped you save a lot of time. Otherwise, you would have done a lot of magical stuff, put a lot of effort to solve this problem. I'm not saying that you don't have to, but there's always a better way of solving every problem that you come across. Is everybody clear?
Yes.
On the screen, Dikshita, Garima, Bibhuvan, Sian, Shanvi, Pranav,
Yeah.
Asrit. Here?
Yeah.
So again, don't do anything interesting. Now, here what I'm saying is, you all would have solved the problem by yourself, using your own technique. Why do you need an old man to explain all these things? Because there will be times when you can find some of my techniques even more interesting. Not only with me, when you work on some problems, when you discuss those problems with your friends also, sometimes you'll find that your friend has a better technique. No harm in learning that for yourself. So always discuss, exchange information, knowledge. That will make you a better student, a better performer when it comes to doing that in the exam. Okay. So question number 2 is gone down now. Yeah? No doubt about question number 2, Advik? Okay. Everybody clear with what I did? Okay. Now let's go to question number 4 and 5. Let's see. Don't make unnecessary sound. Not interesting, not funny, not appreciable. Okay, now the question number 4 says this.
Oh yeah, that's the same problem.
Calm down. Okay, the question number is 4 is, this is 8. This is a mark. Whenever you see a mark like this means 90 degree. Okay, it's a right angle. This one is B. B stands for, B is the first letter of my name, Virendra Kumar. Okay, and this is A.
The last letter.
This one is 20 and this one is 10.6. Say the value of B is what? There are 4 options given: 6.95, 8.4, 9.31 and 11.55. So again, the same boring method of mind, Tran that I call it. Read the question again, analyze.
Read it.
I will add one more thing for you in my Tran. I'll make it L Tran, where the L stands for listening. Okay? Because listening is also a very important skill, correct? When you listen carefully, there are a lot of things, your possibility of learning things improves. Okay? So L Tran, E Tran, a lot of things that we learn. For now, look at the question. Read it. Okay, you are reading it. Okay, this is a right angle. Okay, fine. This is a right angle triangle. This is a right angle. Then I have this as 8 centimeter or 8, whatever it is, whatever unit it is. And then this is B. This is A. This is 10.6. This is 20. Somebody is asking me to find out this length B. Now, first thing is, if I just focus on this triangle, what is this looking like? This is a right angle triangle, where I know this length, I don't know this length, but I know the hypotenuse 10.6, that is already given. Yeah? Now comes the interesting part of it. You laugh for next 20 minutes, then I'll resume, okay? If laughing is so very important in the math class, you do laughing first, then we'll continue. Here, this square plus this square. I'm just looking at this. Let's say if I give it a name A, B, C and D. I'm looking at the triangle ABC, meaning this triangle. Let me highlight it for everybody else to be able to see. I'm looking at this triangle where I know this length is 8, this length is B, which we have to find out, and this length is 10.6. Okay? And this is a right angle triangle, as we can see. First thing, this is the hypotenuse. So this is the biggest side of this triangle. Okay? So this side cannot be bigger than this for sure. This is hypotenuse. Hypotenuse is always the largest side. Okay? That means anything which is more than 10.6 is ruled out. This one is not a possible answer for sure. Okay? Now I'm going to this one. So a square plus b square equal to 10.6 squared. Okay?
So 9 plus 16
Okay.
plus 64 plus 36.
Okay, that's okay. So go slow. That means 64 plus b square equal to 10.6 square. I am a little lazy guy right now. I am not wanting to spend a lot of time. Okay, I don't want to multiply 10.6 into 10.6. That will take me a little bit of time. Just because I have a couple of options to choose from, I want to go a little fast. Let me round it to 11. 10.6, I will make it 11. So that if I say listening, I will try and this listening is it has to be done at every stage. Okay. Now I am just rounding it for getting a guesstimated view that okay, see 6.95, 8.4, 9.3, there's a large difference between them. I'm just rounding it, so say 11, make it 11. Let's see what happens. 11 square. Now my b square will be equal to 11 square, 121 minus 64, which is nothing but 1 minus 4 is 7 and 11 minus 6 is 5. Almost 57, maybe little less because I rounded from 10.6 to 11, so maybe 54, something like that. So b is nothing but square root of 57. Now this is square root of 57. It has to be something less than this, okay? Little less than this. Now 6 square is 36, 7 square is 49, 8 square is 64. This is 57. So it has to be square root of 57 or something lesser than that. So it cannot be 8. This is also gone. Or 9. What we are left with? This. Did we do complete calculation? We did not. What we are doing is we are listening to teacher, and then we are trying to use the elimination technique to get to the right answer. If I had gone with the approach of doing 10.6 into 10.6, we all know how to do it. I'll say by 10, this gone, this becomes 53 by 5, and this is 53 by 5. 53 times 53 will be 9, 3, 5 is 15, 5, 3 is 15, 5 is 25 plus 26. 9, 5 plus 5, 10, 6 plus 1 plus 1, 8, 2809, 09 by 25. That means 25 1 is 25, 3 0, 25 1 is 25, 5 9, 25 2 is 25 2 is 50, 0.9, it would have given you something. So it would have, see, I would have, hold it. You don't have to keep on murmuring all the time. It is not productive for you, not productive for me, not productive for the entire class. And that holds true for everybody. So, I'm trying to convey a message, and that I can do only if I'm going to put my thoughts together. See here, 10.6, I rounded to 11, and I got 11 square is 121. If I would have done all this calculation, I would have gotten 112. The difference would have been only 9. That would have been good enough to still knock off this one. So, I'm teaching you guys the concept behind how do you optimize your effort. Instead of doing all this calculation to get to this, I said, okay, fine, let's round it to nearest possible value, 11.6, 10.6 is almost 11. We'll see how big the differences are. If these numbers would have been very close, then you had no other choice but to go take the lengthy route to solve it. Right? Here, since the difference was quite a lot, so I just rounded it to see, how soon we can solve it. Yeah? Is it making sense to everybody, or I'm just teaching myself? Okay?
So the 20 centimeters is just a trick?
No, it's an estimate.
No, the 20 centimeters, the bigger
See, It is, okay, now it is as simple as, the question is, here in this diagram I have 20 centimeters given as another information. There will be a lot of information around you all the time. Even if there will be questions where you need 3 information but you will be given 5 information. You have to filter out the information that is important for you to solve the problem.
So we don't use.
When I looked at this triangle, it's very simple. It's asking me to find out B. If I have to find out B, this is the right angle triangle. I know one side, I know hypotenuse, I know this is 90 degree. Then Pythagorean theorem is enough. I have one uncle who is helping me solve this problem. Why do I need to look at my uncle's neighbor? Do I need to?
No.
Is that neighbor exciting enough for me to even waste my time for him? No. So we'll not go there. So that's why, that's where the A of tran is very important. This is when you analyze. When you have looked at this information, you have done your analysis and say, fine, my job is getting done by only focusing on this piece of information. Why would even I look at other sides, which is outside? Yeah? So every problem you solve, there is going to be a little bit of application of intelligence needed, and that will come with practice. I am not saying that I am intelligent or you are intelligent or somebody is more intelligent. I am saying that it comes with practice. Okay, when you practice, then you will see, okay, now I know with my enough experience which one to look at, which one to ignore. Yeah? Is it making sense to everybody?
Yeah, makes very good sense.
Everybody on the screen?
Yes.
Okay. So this problem is also done. Yeah? So question number 4 is also knocked down. Garima, Sadli, Ashrit, Pranav, Bibhuvan, Vivan, everybody clear? Dikshita?
Yes.
Yeah. See, unfortunately you are dealing with a very nagging teacher, okay? I don't let anybody sleep. Anyway, this is not the time to sleep. But that is my only means to make sure that I don't have to teach it again to you. I mean, I don't mind teaching the same concept multiple times, but obviously it feels good if it is done in lesser number of attempts. That's why I'm asking it now, rather than kind of, realizing after 4 months that, oh, I did not teach it well. Okay? Now let's go to question number 5. This time I will not do it.
We will.
I will not let you guys do it either. But I would want to hear from you guys about the concept, the approach part of it. Okay? Okay. Hold it till I draw it on the screen, on the board. Triangle ABC is shown below. Okay? Triangle ABC. This is triangle ABC. All interesting jokes, funny discussions are to be kept on mute for next 20 minutes. Triangle ABC is shown below. This is A, this is B, and this is C. Which of the following is the closest to the perimeter of triangle ABC? Okay? 6.0 centimeter. This is 7.3 centimeter, and this one is not given. Which of the following is the closest to the perimeter of triangle ABC? The options you have are 21.0 centimeter. Advik, hold all your humor for next 20 minutes.
Okay.
17.5 centimeter. 16.3 centimeter, 12.6 centimeter, 9.4 centimeter.
Just come on.
Yeah.
What's the first option?
21 centimeter.
Oh, I thought.
Okay. And nobody has to rush to give me a wrong answer. I would appreciate you guys more if I hear a very thoughtful response. Don't jump to impress me by giving a wrong answer. Okay, everybody, I'm repeating the question one more time. This is the triangle ABC. This is 6 centimeter. This is 7.3 centimeter, and this side is not known. But we only know this is 90 degree. And we are given 5 options, and the question says which one is the nearest correct answer for the perimeter of this triangle.
Do we have to like say the concept or do we do it in general?
You have to tell me the concept. You have to tell me what is the possible answer and a conceptual layout of what did you do to arrive at that conclusion.
Thank you, teacher.
Everybody on the screen. Everybody got the question, right?
Yeah.
Are you on the screen? So, nobody has to solve it. I am trying to get a very thoughtful answer from you guys, which primarily depicts your approach towards solving this kind of problem.
I got the answer. I think I got the answer. When I see it.
I'll be highly disappointed if I get an exact answer for anybody say, okay, it is 2.92 because I calculated. Because I'm not really interested in knowing the exact answer. I'm interested in knowing how you're going to approach this kind of problem. Anybody ready? Arav.
How did you get it if we got this menu?
So Ashrit, Bhuvan, Pranav, Vivan, Sanvi, and then Thanu. Yeah, ready?
Is it 17.5?
I don't know.
It's not.
You said 13.5, you have to justify why.
Can you write it?
He did not do it.
Can you write it?
No, don't write it.
Arav, I don't appreciate unnecessary stuff. So anyway, don't engage into those things.
Like in the past, we like write like 1 for like the 17.5. You put like a tally or something for like the answer.
No, you have to explain me. You have to narrate a story. You have to tell me how did you arrive at that. Yes, do it now. I want to hear
Okay,
it.
so the a square is 6 and the b square is unknown. Stop. And the 7.3 is the c. So 6 squared is 36.
That's fine.
Arav, can you let him complete now?
And the 7.3 is squared to the 7.3 squared is 17. My mom had 53.29.
Okay.
And if we move the a square on the other side, we get 17.29 as the b squared. And I estimate that's about 4.2. So 7.3 plus 4.2 is 11.5. Plus 6 is 17.5 centimeters. That's the total height.
I got this in interesting.
Okay. I got your answer, but I'm still trying to look for a more convincing answer. Okay. Even more convincing story. Let's see who gives me that story.
Alright, so basically what we do first is 7.3 squared equals 6 squared plus b squared. Then we do 53.29 equals to 36 because we convert 36 squared into 36 plus b squared. Then we move into positive because 36 is positive, we move into negative. That equals 23.29 equals b squared. Now we have to figure out the square root of 23.29 equals b squared, so we can take out that square. And now I need a calculator.
Now you need a calculator.
Because
So,
I need to
okay.
get this one.
Is it really that hard?
Okay.
It's too hard.
Okay. Hold it. When I will give my story, probably you'll find something different from the way you have looked at it. Okay. Let's see what we want us to say.
But sir, so first, I added 6, I rounded 7.3 to 7. And I added them with, no, I did 37 and I subtracted what I got. And then I got 33.
Alright. Yeah, sorry, go ahead.
And I rounded the square root to 4. And I added them all again, which added up to 17.5. Like approximately 17.5.
Okay, that's one approach. You just rounded because you were not wanting to waste so much time doing the exact calculation. So Arav and Amit, you both, when you were doing it, you were trying to do it the right way. I'm not saying that was wrong, but the intention is not to get the exact answer. I mean, because since you have few options here, you have to round it to get to the nearest possible one, unless you get to a situation where it's very confusing between two. Okay, so this is one of the. Okay, I have one more student who is ready to give the answer. Let's hear everybody. I was just sharing with you guys because you guys were talking to each other. I was just getting your attention. Yes, Ian.
So basically what I did, I found the square root of both of them, and I didn't want to do the exact square root of 7.3 because that would be more work. So I did it to the square root of 7. Then I got 49. Then I did 49 minus 36, and I got 13. And 13, I don't want to find the exact square root of that. So I got around 4 because that's the closest square root. And then I just did 4 plus 6 plus 7.3. And I got 17.3. And the closest answer to that is 17.5. So I chose that.
Yeah,
Yep.
that's the same answer.
Yeah. Okay. So everybody got the same answer but with different approach, right? Ultimately what matters is how much time you are spending to think through it, and then what is the minimum time, how you are optimizing your time for solving it, right? So, I mean, none of the approaches are wrong. It's ultimately boiling down to how quickly you can do it without going wrong. And now I will tell you guys one more approach, okay? Once I hear one more answer. Anybody else wants to share?
Well, I already shared my attention.
Okay. L-Tran. Now I have got a silver bullet to put a sellotape on your lips. That is L-Tran. L stands for listening. What did I say? Anybody else in the class wants to share the answer. That anybody has to be somebody who has not told already. Oh, and now I'm taking English classes also for you guys, which is one of my poor subjects. Okay, alright, stop it there. Now, what I was telling you guys was, when you are dealing with a multiple choice question, okay, when you have multiple choice, you have two ways of doing it. One is, you solve it and you get the exact answer, or second technique, which works in 90% of the scenarios, is called elimination. How do you eliminate the options? So, I will do some big borrow still here, okay, like two concepts. One is my elimination technique, and one is the technique that you guys use by rounding it. So by rounding it, you say, okay, this is 7 and this is 6. One thing I know from this is, okay, can I have that? I have 7 and I have 6. This is my hypotenuse. So this is the largest of the three sides. Okay? And this is already 6. When I am dealing with 7 and 6, square of this plus something will give me 7.3. See, the difference between this and this is only 1.3. So this number is certainly not a big number. It cannot be 3 or 4 or 5 kind of a thing.
It can be 21.
Understand? Okay. So it cannot be 3, 4, 5. It cannot be a big number. So that means 6 plus 7, 13 plus 5 or 6 will, that only I get to 18, to 21. So this option I cannot take. This is gone. Now I already have 7 and 6, that is 13.3. So this is out of question. This is also out of question. Okay? Now 7 plus 6, 13, 3.0. Now the question is between these two guys. So even without solving anything, I could see 7 plus 6, 13, 13.3. So this is gone, this is gone. And then when this is 6 and 7, the difference between these two is only 1.3. So when you look at the square, this is not going to be a much bigger number. So this also can be ruled out, but if you still want to keep it, keep it. Now look at the rounding approach. So I ruled out two of the options without doing any calculation. Now let's round it. So this is 749. 49 will be equal to this square plus this square. So 6 square is 36 plus this one is square. I don't know what is this, so I'll say b. So this becomes, b square. B square will be equal to 49 minus 36, 13. So b will be square root of 13, which will be less than 4 for sure. 7 plus 6, 13. So this is less than 4. So this is also gone. Because 7 plus 6, 13, even if it is 4, that only makes it 17 point something, right? So 21 is out of question. Now the question is, which of these two is looking more closer? So this is 13. 3 square is 9. 4 square is 16. So let's say 3.5. I'm just going somewhere in the middle. So if it is 3.5, then it becomes 6 plus 7, 13.3 plus 3.5. So 13.3 plus 6.5. That gives me 19.8. Sorry, 13 plus 6, 9. What did I do? Oh, this is 3.5, sorry, my bad. So this becomes 13 plus 3, 16.8. And this is 16.8, this is 16.3. And this has to be more than this because we had rounded 7.3 to 7. So this is more than this. Correct?
Yeah.
So 16.3 and 17.5, your number is somewhere above this. So the only option that you're left with is this. So, no, nothing to clap. I was not giving a speech any which way. Now, if you want to summarize this, like with this approach, we had a multiple choice question. Two things we did. First of all, every extra information that you have in the problem that is not needed is nothing but a nuance. That wastes time. Let's say if you have a question, you have 5 extra information. You have 5 or 7 options. Every option, if you have to validate, that is going to kill your time. That is why I am calling it a nuance. So here, just by looking at these two sides, we talk about perimeter. That means this side plus this side plus this side. 7 plus 6 is almost 13. So this cannot be something I want to waste my time for. This is something that is not holding enough water for me to even look at it. These two are already gone. Then I am left with these 3. Even if you don't go by any other approach, you can do a rounding. Say, okay, if it is 7.3, let me do it to 7.7, or I can do 8, whatever you want to do it. And then based on that, you find out what is the nearest value, and then you apply a judgment to see which one it is closer to. So, just by solving it, by doing all the hard work, might give you the accurate result or the right result, but that might eat up a lot of your time in an exam where you are hard pressed for time. So that's why some of this combination of hard work and some techniques help you save some time, which you can use for solving other problems also, and don't run out of time to finish things within the stipulated time. Yeah. Was it too much of a dose or it was okay?
It was a little.
Mm-hmm. It was a little because the L track.
Yeah, I applied it to my time and
Okay.
it worked.
Alright. So, everybody got it? Garima, Bhuvan, Shriyam, Dikshita, Pranav,
Yeah.
Ashrit, everybody understood?
Yes.
Sanvi, clear to me, beta?
Yeah.
Okay. No, that ya was sounding a little low.
No, I'm just tired. I'm just
Yeah,
tired.
okay. Now, so see, when you guys say, yes, I understood, that gives me that is distracting. So, when you say yes with a very firm voice, that gives me a different message compared to, okay.
Hold on.
that compared to when you sound little low. Okay. Anyways, let's. How much time do we have? We have.
It's 9:56. It's 4 minutes approximately.
At 2 minutes you will eat up just blabbering about it. So don't do that. So next question, okay, question number 11. You will not try solving it. I'll just give you the approach, okay? It'll be just an extension of what we have discussed so far. So let's look at it. Number 11. 11 is Advait. What is going wrong with you?
Nothing.
Then control yourself. No, this will not be entertained.
Okay.
Here I am just saying Advik and I am stopping it there. If you do the same thing in the school, you'll be taken to principal's office. You know that, right? You can get it. Don't commit mistakes where you end up unnecessarily, covering up for it for no reason. Where did the question number 11 go? Who had looked at question number 11? Where was the question number 11? I have given you guys. Even the third page, this one has first page has 5 questions, second page has 2 questions, 3 questions, makes it 8, and the third page has 3 questions, okay?
No, but like.
Okay, we have only 2 more minutes. If I entertain your blabbering, that will waste the whole time that we have. Let me read the question again.
This is strong.
I'm coughing.
A ladder 12 meter long leans against a wall. So this is a wall, a ladder 12 meter long. This is 12 meter long. Leans against the wall. You don't have to keep on saying okay after every sentence. I have full stop and comma in my sentence, okay? I don't need to borrow from you. A ladder 12 meter long leans against a wall. The foot of the ladder is 190 centimeter from the wall. So foot of the ladder is 190 centimeters. 190 centimeters.
I thought it said 80.
Doesn't matter. It's okay. From the wall. How far up the wall does the ladder reach? Okay, so this is the ladder which is 12 meter long, and the foot of the ladder is 190 centimeters from the wall. From the wall. How far the ladder reach? Meaning, what is the height? This height. Again, this is a wall. This will be 90 degree. This is 190 centimeter, and this is 12 meter. Remember one thing: don't get confused or don't overlook the unit. Okay. 190 centimeter is 1.9 meter. Convert everything into one unit, okay, so that you don't get confused between the calculation part of it. Be very vigilant about the unit used and then apply that. Now this is 12 meter, this is 1.9 meter. What you have to find is this. And then everything is calculation. You can always use the Pythagorean theorem. This square plus this square equal to this square, and then from that you derive it. So any question that you come across, first thing is your effort, your time, your investment has to happen to understand what exactly the question is. If you have understood the question well, the chances of you doing it right is high. If you have just skimmed through the question and you think that you can straight jump onto it to do magic, magic will actually happen, but that will be negative magic, or sometimes it's called black magic, which will take your answer for a ride.